Now we're going to look at a second method of solving quadratic equations, and it's usually called completing the square. This is for higher students only, and the algebra gets a little bit tricky, so stick with it and see what we get. Okay, we're going to look at ax squared plus bx plus c equals 0, but here a is going to be 1 to start with. Things get a little bit more complicated when a is not 1 in this situation, and this is complicated enough as it is. The first thing we're going to do is look at the x squared plus bx piece and just forget about this c for the time being and deal with that later. So we're going to look at x squared plus bx. Now to complete the square, what we're going to do is we're going to break this x squared plus bx into a perfect square and a little bit at the end. To do this, we basically halve this coefficient, the b coefficient, and put it into a bracket so that it says x plus b divided by 2 in brackets all squared. This is our perfect square, and subtract the bit we don't need, because when we expand this out, we'll get an x squared. We'll get 2 lots of bx over 2, which will give us the bx, and then we'll get b over 2 all squared as the final part of the bracket. So we need to take that off because we don't want that. If it all sounds complicated, just bear with me. So the x squared plus bx reduces to, or looks more complicated by, whichever way you want to look at it, this x plus b over 2 all squared, and then we subtract the b over 2 squared afterwards. We can then use this to solve our equations. In the exam, they may ask you to solve the equation by completing the square. So make sure you do this method and not any other method. So let's look at an example of completing the square. We're going to look at the x squared plus bx piece. So let's look at x squared plus 10x and put that into a perfect square with a little bit hanging off the end. We're going to use this little formula with b equals 10 to put x squared plus 10x into a perfect square. So x squared plus 10x becomes x plus 10 divided by 2 all squared minus 10 divided by 2 squared. And 10 divided by 2 is 5, so we have x plus 5 all squared, and 10 divided by 2 is 5 again, and we're subtracting 5 squared from it. So we have in the bracket x plus 5 all squared, and 5 squared is 25. So it's x plus 5 all squared, and then we take away 25. So this is the bit we need, the x plus 5 all squared minus 25. That is our square, or completing the square piece. We can check that this x plus 5 squared minus 25 is correct because we can expand the x plus 5 squared out using FOIL or any other method that you'd like to use, and we get x squared plus x plus 5 squared, x times 5 squared, x times 5 squared, and then 5 times 5 squared, which is 25. That gives us in this bracket x squared plus 10x plus 25. We have the minus 25 at the end, and then 25 minus 25 leaves us just with the x squared plus 10x, which is what we started with. So it may look complicated, but in the end we've converted x squared plus 10x into x plus 5 all squared minus 25. Now have a go at trying to put these expressions into a completed square form. X plus q all squared plus r. Notice that in the bracket the plus may be a minus, and outside the bracket this will probably always be a minus, so just take care when you're solving these. In books they always write it in the form with a plus, but just take care that there'll be minus signs here. Pause the video and have a go at doing these. So here are the answers. X squared plus 4x. I've halved the 4 to give me x plus 2 all squared. And then we have to take this 2 here and square it and subtract it from the brackets to give us the final answer. Here we've got a negative sign. We half minus 4. That gives us minus 2. So it is a minus inside the bracket here. And we've got x minus 2 all squared. Subtract 4. Half of 14 gives us 7. Half of minus 14 gives us minus 7. So x minus 7 all squared. Then we have to take off the minus 7 squared. Minus 7 times minus 7 is plus 49, so we have to subtract the 49. This is a little bit trickier. We get into fractions, but it all still works. The half of 1 is a half, half squared is a quarter, and we need to subtract that off. Similarly here, half of 3 is 3 over 2. It's easier to write it as a fraction, 3 over 2, rather than 1.5 or anything like that, because it will make your life easier when solving the equations. I know you love fractions, but it does make life easier if you keep it as a fraction. Okay, this slide looks a little bit complicated, but let's just go through it. We can now solve x squared plus bx plus c equals 0. First of all, we take the x squared and bx and break it down into our perfect square with the bit subtracted. We stick that back into our x squared plus bx plus c. It all looks a little bit horrible here. X plus b over 2 all squared minus b over 2 squared plus c equals 0. But we now use our rearranging techniques, which you've practiced in previous lessons. We take the c over to the right hand side and the minus b over 2 squared to the right hand side to give us x plus b all squared equals b over 2 squared minus c. We then have to get rid of the square on the left hand side, so we have to take the square root. That's what this little sign here is. And remember, we can have a positive or negative value for a square root. So we get x plus b over 2 equals plus or minus the square root of b over 2 squared minus c. And then we can take the b over 2 from the left hand side, move it to the right hand side, it becomes negative, so we have x equals minus b over 2 plus or minus the square root of this. Now when you're working this out, you won't see all this algebra because you have numbers here and you'll be working them out as you go along. So we'll look at that in an example on the next slide. It's an example that we've used before, so we know what the answer is going to be, and we can just double check that as well as doing it by factorising, we can complete the square and get exactly the same answer. So we're going to look at solving x squared minus 8x plus 15 using completing the square. First, we're going to break down the x squared plus bx bit, so that's the x squared minus 8x into the perfect square. If I can find my slide. So, breaking that down, the minus 8 becomes minus 4, so I've got x minus 4 all squared, take away the 4 squared. So I've got x minus 8x becomes x minus 4 all squared minus 16. I can then substitute that into the original equation. So I've got x minus 4 squared minus 16. That's replacing the x squared minus 8x. And then I add the 15 on, and that equals 0. We can make that simpler by rearranging x squared minus 4, x minus 4 all squared, take the 16 and the 15 over, and 16 minus 15 is 1. So we've got x minus 4 squared equals 1. Now we take the square root, so we've got x minus 4 squared, take that square root, leaves us with x minus 4, and we have to take the square root of 1, and the square root of 1 is going to be 1. Don't forget our plus and minus signs. So, once we've done that, we take the minus 4 over to the right hand side and it becomes plus 4. So our solutions are x is 4 plus or minus 1. That is 4 plus 1 is one of the solutions and 4 minus 1 is one of the solutions. And if we just write that out, 4 plus 1 is 5, so one of the solutions is x is 5, and 4 minus 1 is 3, so the other solution is 3. And x equals 5 or x equals 3 were the solutions we got when we factorised that. So completing the square, yes, a little bit more difficult than factorising, but we can do it and we get the same answer. Completing the square will work when factorising doesn't work. That's the whole point of learning how to do this. Okay, over to you now. Try these by completing the square. The first 4 we've already done by factorising, so you do have the answers to those already, but try and do it by completing the square and working through and rearranging the equation to get down to x equals plus or minus 2 numbers. The last 2 are new, but you should be able to solve those by completing the square. Have a go at these, pause the video, and we'll look at the answers in a second. Okay, here are the answers. I'm not going to go through each one in turn, but just double check that you're okay getting those answers. If there are any problems, maybe have a look at the video again or look at some other videos on YouTube and see how you get on. So this is completing the square. It's another way of solving equations, and in the exam they will specifically ask you to solve a quadratic equation by completing the square.